Hello, everyone. I'm Danielle. I'm a third-year PhD student in the Rehabilitation Science program, and today I'm going to be talking to you about literature searches, downloading the UAB VPN and all that, accessing the library, getting these documents onto your computer, and also formulating review questions for when you're writing a paper. I want to apologize for being kind of late on uploading this video. I realized that I hit some hiccups when I was recording last week's video and I didn't share my screen completely, so the things I was demonstrating didn't show up and it stayed on the PowerPoint. So I wanted to re-record this and upload it. Even if you don't get to view the video, that's fine. Just look at the PowerPoint and hopefully it's helpful for you as you're conducting literature searches and working on bachelor's thesis, other papers, things of that nature. So I'm going to share my screen now and I'm going to show you, my PowerPoint. All right. Literature searches and review questions, right? So we'll just start off and I'll introduce to you the key databases for any medical science major, Pubmed, the main one, but you can also, especially as you get more into human behavior and psychology, PsycInfo is good, Scopus is good for across the board different types of article generation, and of course Google Scholar. Google Scholar and PubMed are my favorites, but I really like Scopus as well. And again, I broke down some databases that would be relevant to you guys, particularly PubMed and Scopus for immunology and these heavy bench science and mechanistic kind of research papers that you may be looking for. Scopus definitely. But then if you're interested in behavior and psychology and clinical application and translatability to human health, definitely PsycInfo and always PubMed. And of course, Google Scholar. All right, so if you need a general overview of your topic, there's the Clinical Key and R2 Digital Library, both great. They have sources with electronic databases that have very broad general overviews of health science topics. You could go to Clinical Key or R2 Digital Library and look for any kind of immunology topic, and it'll kind of help you generate what I like to call subject terms, and those subject terms will build into key terms. And those key terms are what we'll be using to look for literature to formulate our review paper. But first, let's talk about accessing literature at home, because many of us aren't going to Lister Hill Library or Stern Library, and we're not sitting on campus all the time, although some of you may be living in dorms, so you do have access to the Wi-Fi. For those of you who don't, or you're at home, or you're just not around on campus and you're not on UAB Secure, you can download the UAB Cisco VPN so you can access articles. Also, you can log in to the Lister Hill Library website, which is very useful. But you can always start your search on UAB Library's homepage so you can have access to the articles that UAB has paid for. And I'll demonstrate this for you in just a second. First, I'll show you how to get the VPN. And the VPN is your virtual private network. This could be useful for getting on a canvas. If you just have to absolutely do things through UAB servers, then this will be great for you at home. If you, for instance, have a UAB MC email and you can only access certain emails for your research lab, this is what I use to access my lab email at home. So because I can't log in through my regular IP address. So I provided you with the link to the website. I already have it pulled up. Wait, nope, gotta remember to see what screen I'm sharing. So now I'm going to show y'all this guy. And what I'm going to do is I'm going to put in this link. There we go. Go to this link. VPNIT UAB. And right here, your virtual private network, you can access this. Here is how you'll access it. So you'll go here, download the 64-bit system. That's what I get. Works faster. Then here's your Windows installation guide. Useful stuff talking to you about how to download it, how to get it onto your computer. And then, so there's your installation guide. I provided the link in the PowerPoint. Also, remember, when you're logging in, it's going to give you it's going to show you a username and then 2 passwords. Your username is your Blazor ID. The first password is your Blazor ID password. The second password is the Duo Push Mobile, whatever code that thing generates that's on your phone. So that will be your Duo enrolled device will be your second password for the VPN. And again, the VPN is very useful. You will automatically have access to all the articles UAB has access to. This will allow you to check your email if you have UAB-MC or hospital-based emails that you can only check when you're on campus, things like that. It's very useful. I've used it several times, didn't know about it. So yeah. So the next way to get access to articles, because I'm not logged into the VPN. So I use the UAB Lister Hill library. You can also use Stern library, but I just prefer Lister Hill. Easier to use. Go right down here to Pubmed, Hall, Scopus, Google Scholar. But to access articles, what's important is you click here to begin your Pubmed search. And notice how it triggers me to log in, right? So then I log in to Pubmed. Or I log in and it takes me to Pubmed. Great. So now what I can do too is I can go back to Lister Hill Library since it triggered me to log in. Then I can click on Google Scholar and click there to begin my Google Scholar search. I will tell you, if you click on Google Scholar, it won't trigger you to log in. It won't get that started. However, if you click on Pubmed through Lister Hill, it will start your login with your ID, and you should be able to access most of the articles available or paid for by UAB. Okay. So let's go back to New Share, back to the PowerPoint. Great. So I showed you the link, and again in the PowerPoint, I just wanted to demonstrate. Here's the links to the tech solutions and how to set it up, how to get it installed, how to log in. These links are provided for you, and they're all on the website I just showed you. So now that I've showed you the VPN, let's talk about how to search databases. There are ways to search databases that can help make your search more concise and more thorough, and just get out those unnecessary articles you don't really need. What you do is kind of like a 3-step thing. First, you identify your key concepts and the main ideas that you're interested in. Then you use keywords or subject terms, which is what I like to do, especially in the context of this demonstration today. I'm going to use subject terms like immunology research technology, right? That's my subject terms. And I'm going to use that to generate keywords such as the specific technology that I'm interested in searching for. And then we're going to combine those terms with connectors like and, or not. Very powerful, useful tools for eliminating unnecessary articles and things that are just kind of not really pertinent or working towards the focus of what you're trying to achieve here. So I'll start by talking about subject term searching, which it has some advantages. Usually it's got relevant hits on there. It might help you narrow your focus, get you some more narrowed focused terms that you're interested in, get you some ideas generated, and it also will return all the items indexed in this database. So you're going to get a lot of return on what you're doing here. You're going to get a whole bunch of articles. Some of them will be superfluous, won't really be useful, but it's great for generating those search terms that you're going to use to look up your idea. So it's also sometimes it's a lot of jargon, a lot of extraneous topics you don't need, and then recently coined terms may be left out. Then we get into our keyword searching, and I'm about to demonstrate this for you. But basically, keyword searching gets more specific. When, for instance, I'm interested in vectors or whatever, which we're about to get into that. Well, then you can type in vector, human health, immunology technology, things like that, research, and then these start getting you more specific and add in your connectors. And that's how you're going to pull up those more relevant articles that are going to be more pertinent and help you develop your idea in your paper in a more logical narrative flow. So advantages, it uses this common language that's going to get you more specified articles. It goes across multiple fields. It can be truncated. It may be used in combination with other keywords like I was just stating, like immunology, technology, things of that nature. It can also be used to find information on current subjects, especially on Pubmed. And some disadvantages, often broad, you might get irrelevant hits, not indexed to specific fields, and sometimes multiple search terms are needed. So you might need more, where you can get in one subject term, you may need multiple search terms. But that's the point of doing your subject indexing, because then you find these different words that you're going to use to really narrow down your idea and your focus. All right, so I'm going to share screen again. Let's go here, share that. Okay. First thing I want to do is go to Google Scholar. And I'm just kind of interested in my subject term first. And I feel Google Scholar is a great way, is another one outside of Scopus, especially if you don't have access to Scopus, because sometimes you have to log in. This is a great way to just start your subject term. For me, I'm putting in immunological research technology. So whatever pops up, I'm going to click on and I'm going to start a PubMed search on it. But this is my subject term. And it can also turn into your key search terms, but you're going to specify this. Look at this. All right. So we got organoids and immunological research. We got CRISPR, Cas-R. We have large animal models. So we have a lot of stuff popping up here. And what I really love about Google Scholar is you can favorite it. You can cite it, so you can pull. So I'm just going to say organoids, right? Why not? That's the first thing. I have no idea what those are. I mean, I can use my context clues, but you know what I mean. You can cite it. So here's my citation. I'm going to take that citation and copy it, and I'm going to put it in my awesome possum. And you can't see it right now because I'm not sharing that part of the screen. Ooh, this one. Sure. So now I took that link from Google Scholar. I'm going to copy and paste it right here in my little immunological paper concept outline map that I got going. And we'll put that ref right there for now, and I'll use it in a little while. Or maybe not. So organoids and immunological research, and this is awesome. It was published in Nature, which is a really huge paper, great impact factor. This is what everybody wants to be published in. Nature in 2020, awesome. It's a brand new paper. And it shows you related articles on Google Scholar. I love Google Scholar. Awesome. Here's the link. There we go. Can I access the full article? Yes. Oh, accept all cookies. Yes, I can. Oh, I didn't go back to my share. My apologies, guys. I am such a noob when it comes to this stuff. Okay, so sorry. Anyway, I love Google Scholar. So I wanted to show you some more little neat tricks here. This paper, Organoids and Immunological Research, it was published in Nature in 2020, so it's relevant. And also you can go over here and select your time range. For some of these things, if you're getting the history, maybe select it further back. For me, I like seeing things published since 2015, just to see how the science is changing, because it's changing quite drastically with all the technology we have. Okay, so you can go to cited. You see this article's been cited 55 times. Then you can go to related articles, super cool, and you can see all 4 versions, and then you can see it was published in Nature, and logged into the UAB library, and I can download the PDF. Great. And there we are. So another really awesome thing, this is a super cool systematic review or a narrative review, one or the other. Looks like a great paper. Really pretty figures. So at the bottom here, I'm going to go and see what they got. Oh man, all these figures. So they can really talk to you about how this technology is being used. What a beautiful systematic review. Anyway, I love that they have 175 references for you to pick through. So that's one of my things. When I'm writing a review paper, or I'm writing some introduction, like when I was starting my dissertation, when I started my master's thesis, I went and found the most up-to-date systematic and reviews and meta-analysis and looked at them and saw what they were writing, because this is like the top of the pyramid of evidence, right? So a systematic review takes all of the evidence into consideration. A meta-analysis takes all of this information and does super meta-analysis over all these statistics that we've already generated to give us an idea of what is the overall field saying. What is this idea coming from? What are we seeing in the field? What are the trends? Where do we need to go next? So this paper for you guys in your class is not quite so in-depth, not even by a long shot. You're doing like almost like a very brief report on this thing that you're writing about. However, systematic reviews are a very rich source for you for looking through these articles you may need, right? So I'm not going to go through here, but I'm just saying, if you're writing about organoids, this is a great paper. All right, so I'm interested in organoids and immunological research. So now I'm going to go to Pubmed. And that's how you spell organoids. Let's go to Pubmed, and I'm going to go to Advanced Search. First thing I'm going to write in, immunological research. Or actually, I'm going to put in immunology. Research. And I'll put it in brackets so it knows that it's one term, like this, and I'll add it. Then I'm going to select an and here. And organoids. And I click on and. It also puts it in its own little majiggy, its own little brackets. Then I'm going to put in human health because I'm interested in human health. And let's put in, I'll leave technology out. Let's search it. No, I'm good. Search. Ooh, oh, sorry. So I had clinical trial selected. Great. We got 41 results because I included and. I love and. It's a great connector. And super cool about Pubmed, you can go to the publication date within 1 year. If I select 5 years, it gives me 115 results. Super cool. And it looks like with organoids, a lot of their data has been coming out between 2016, really probably 2013 to 2021. Cool, 125 results with these 3 search terms. And I can go down, and then I can select clinical trials. There were none, so I can select, let's see if there was randomized controlled trials. No, probably not in this type of bench science, heavy bench science research. So we can also put in systematic reviews, see if there's any systematic reviews now. And also, this is a newer feature on Pubmed, so if this thing hasn't been meshed or kind of indexed like one of these, it might not show up, so don't be discouraged if you can't find a meta-analysis. I'm sure it's in there. It's just not categorized in Pubmed's log, their algorithm as such, because this is a brand new feature they've included here. I do like this, the 1 in 5 years. So when I type this in, I look and I see distinct populations of inflammatory fibroblasts and pancreatic cancer, probably not relevant. Human cardiac organoids for modeling of myocardial infarction and drug cardiotoxicity. And then we find more organoids. So, okay, I see that there's cancer. We got some stuff about SARS here, pretty interesting. Human airway organoids. So a lot of good, interesting things here that you can really kind of get more specific on. So apparently organoids are used across a variety of different mechanisms and settings within the human body and human tissues. So I would pick a disease for this. So I'm interested in cancer. Let's add and cancer. See, this narrows this down. 53 results. Great. So you want to really get that, see how I'm getting more specific. Now that I've generated this subject I'm interested in, I used that subject term on Google Scholar, the subject term, which was immunology research technology, and this is how I generated a key term, organoids, or the plethora of other things that you want to use. And then I went to Pubmed and I got super specific. So I used my original subject term, immunology research. Then I used and put in organoids and human health because I'm interested in human health, and cancer. So cancer was me getting more specific. So as you can see with key terms, you're getting more and more specific, so you can really just toss out this unnecessary, superfluous things that really aren't building towards your idea. And you don't want to do a bunch of reading for 1,000-word fucking paper anyway. All right, so I see more cancer, and I can talk about this, and I'm like, okay, not really interested in fibroblasts, still kind of out there. Okay, maybe this got me to, okay, cancer organoids like this. Organoids to study immune functions. This, oh man, this sounds great. Another 2020 paper. It's a review, something you can really pull from. Look at the papers they're writing about. And then for this is very general, very broad over all these different technologies. So you can go in and be like, I'm really interested in pancreatic cancer and its uses, and that will make it a lot easier for you to get this paper, something that's not just you copying and pasting stuff out of a systematic review, right? And so I can see there is full text available at UAB. Awesome. Then I'm going to cite it. I don't really like NLM. I prefer AMA or APA. Here's my APA citation. I'm going to copy and paste that. I'm going to share my screen again. New share. To my concept outline. And that's a second paper I'm going to read through for that. Right? Okay, so this way I have 2 or 3, I can put my references over here, I can put my notes, then I can start talking about getting this, what is this technique, organoids in human neck cancer, why not? Or you can do something, whatever you want to do. Right? Who created it? What problem does this address? What is the overall significance of the technique? All of this is pretty much covered in these systematic reviews. Just don't plagiarize it. And then, you can start talking about the impact, and this significance and impact is where you take your interpretation of what this is doing for the field. Look at the systematic review. What do they say? Find a couple of select papers that are really interesting to you in the references, read those, get a better understanding, and just write out some notes and write some things down and put it in your own words. And before you know it, you got a paper. Anyway, so that's how you generate some key terms, some awesome papers on Pubmed. Ooh, animal and translational models of SARS. I hope some of y'all write about SARS and COVID. That'd be cool. But a lot of things about organoids, there's so much you can write about, right? But, let me go back to sharing my screen. I ain't sharing it right. Anyway, so that's how you can use Pubmed in a really awesome way, and Google Scholar for generating these ideas, Pubmed for really specifying. And I want to demonstrate one other thing for you, the importance of using and rather than or. So if I go in here and put or cancer instead of and, how our other results have what, like 150? Let's see how many results we have now. 4,322,343 results. That's a lot to sift through. So remember your connectors, they're extremely important, and or maybe is more useful if you're not getting a lot of results to come back, right? So put some ors in there. Maybe take out human health. I want to see what happens if I take out human health. So I get 282 results. So when I put in and human health, in brackets, of course, we jump down to 53 results. A lot easier to manage, I would say, and you get a lot of things that are more relevant to the idea that you're trying to convey in your paper. All right. So let's go back to the PowerPoint. And again, if you have any kind of questions at all, please just let me know. I'm more than happy to help, and I will be reading your stuff this weekend. So, okay. So let's talk a little bit about formulating your question. You want a well-formulated and answerable question for a review paper, right? You want this question to be clear, concise, focused, well-formulated, and most of all, answerable. This may be a little bit out of the scope for what you guys are actually writing about for your paper. This isn't a full-on review. This is more just getting a better understanding of immunology and research technology and what's going on in a field of in a topic that you're interested in. But let's talk a little more about formulating these questions, because this may be relevant to many of you who are starting a bachelor's thesis or wanting to go into research. If you're definitely relevant if you're trying to get into a PhD program. Oh, and so when you're talking about your paper, the first thing we think about is our key terms, our topic that we're interested in, these subject terms, and these keywords. What is the purpose of this review? Is it to give a general overview of the field? Is it to investigate how effective a certain technique is across different studies? Do you want to just see, that's, well, obviously the point of a review is to give a general overview, but you want to really get focused with it. What is the topic that you wish to address? Are you answering a specific research question? Because meta-analysis is used to answer research questions at the meta level across all of these fields, all of these studies. What is, when we take all the statistical data together, what are we seeing? What are the trends? Then that's when you get your subject terms, then you define those key terms like we just did, and understand too, what do you precisely mean by the terms that you're searching for? You want to really know the definitions and know what these things are, or your search is going to be rather difficult and not very fruitful. So there's two methods that I use when generating research review questions, or just helping myself come up with ideas about research problems and topics that I want to address as I'm writing grants, as I come up with ideas for my dissertation, my bachelor's thesis. So I call these the Pico and CMA method. Pico. The Pico approach is used in medical science and clinical science a lot, and we define this topic of interest and key terms. Then we begin to structure this focused, answerable question. And Pico stands for population, intervention, comparison, and outcome. And for the P part, population or problem, what's the problem in the population? What is the evidence required to answer this problem in this population? What are we missing? Then we have intervention. Intervention is the effects of this event, action, or activity being studied. This can be an intervention. This could be something going on in the environment. This can pertain to epidemiological studies, cross-sectional studies. This intervention doesn't mean randomized controlled trial. Intervention is just what's intervening. What is that independent variable that we're studying? Then we can kind of get more into the topic, which is neck cancers with organoids, right? And what's been done in this? What is currently being done to treat this? What is the gold standard treatment for this problem? And you can see how this is a little less applicable to this heavy bench science mechanistic research, more applicable to the human component in clinical science and things like that, human-based research. But again, the intervention is the independent variable. What is being studied? What's the event, the action? Is there something intervening here? Then we have our comparison, the C part, the Pico. What is the alternative to the gold standard treatment or the intervention? Are there placebos, different interventions, alternative things to this treatment or to this thing that we're interested in? And again, you can, if it's an exposure in the environment, well, what happens when you're not exposed to this environment, to this thing? You know what I mean? What are the alternatives in this comparison? What are we always comparing what we're interested in, this independent variable, back to? What are things that could be confounding this association? All of these variables and comparators to help us know, is what we're studying actually doing what we want it to do when we compare it to something else? Then you have outcomes. And the outcomes are, what are the effects of this intervention, this action or event or thing being studied? What effect does it have on the dependent variable? What are the outcomes of interest when pertaining to organoids? What do we want to see change? What are we hoping to see change? In human health, typically this is related to quality of life, a functional outcome, cognition, mental health, things like that. But in bench science, the next method's going to be a little more applicable. But that's Pico. That's what you're thinking of when you're getting more into this human research and clinical translatability things. An example of a well-formulated question here, whether a particular antiplatelet agent, such as aspirin, is effective in decreasing the risk of a particular thrombotic event, stroke, in elderly persons with a history of stroke. So as you can see, when you break down this question, here's the intervention, aspirin, an antiplatelet agent, so it doesn't have to necessarily be an entire clinical trial. Oops, didn't mean to do that. Okay. Sorry. Then you can see what we're interested in, and the outcome is decreasing the risk of a thrombotic event in our population, which is people with a previous history of stroke. So there's our thing, our intervening agent. Here is our outcome that we're interested in, preventing stroke, and this can really be broad. So don't pigeonhole yourself into thinking it has to be a very certain thing. It's applicable to many things of detailing human health and research. Let's talk about CMO. CIMO. So the CMO approach stands for context, intervention, mechanisms, and outcomes. And this method is probably particularly relevant for you guys. And it is the study of complex questions in multidisciplinary topics. So we therefore recommend CMO. And the C is context. So again, what is the population being studied? What is the relationships or institutional settings or other systems being studied? So what organ systems are we looking at here? Are we looking at animal models, human tissue? Where are we applying it to? Is this something, are these human, animal models, human tissue, what's the setting being studied? Are we looking at some big organizational, big data questions, things like that? So what's the context here? What are we looking for? And again, you can also be looking at this in the context of a population of interest too. Like, what in older animals, like Alzheimer's research and older animal models, does this also apply to older humans, things like that? Then we go to, again, this intervention. What is the independent variable, the event or action or activity being studied? In this case, for me, it would be organoids and their application to furthering human health research. We go into the M, which stands for mechanisms. So this is more, what are the mechanisms in particular in the bench science and this very mechanistic kind of immunological research? What are the mechanisms that explain this relationship between the intervention and the outcomes, between the dependent variables and the independent variables? What are the circumstances these mechanisms are activated or not activated? So when are organoids useful? When are they applied? When are they not useful? What human disease are these most useful for studying? Is it cancer only? Do we also investigate viruses with it? Do we also look at pneumonia, different things like that, bacterial infections? What effect does this have on aging? Things of that nature. Then we talk about the outcomes. What are the effects of this dependent variable or this independent variable, this intervention or technology or procedure that you're interested in? And what effects does this have? How does this further research? What are the outcomes typically when you're researching organoids, which I have read no papers on those. I don't know the outcomes. How will your outcomes be measured? How are you measuring this? What is the outcome? How are you measuring it? And what are the intended and unintended effects? Is there some sort of antagonistic or agonist effect of organoids? Which probably not, but what's the downstream effects of this thing in the system that we're studying? So in this human immune system or animal immune system or these cells in vitro studies, what is the downstream processes going on after we turn this thing on or flip the switch? So that's CMO. And again, with CMO, we can kind of see that the context here, and for instance, with this, our context is previous history of stroke, elderly people. Our intervention, or what we're trying to study, is aspirin. And our mechanism, which you could probably get a little more mechanistic than this one isn't talking about mechanisms, it's looking at risks in human health. But then we could get into, does a particular agent look at different levels in the blood. Like, so you can say, what are the levels of this agent in the blood? What is it inhibiting? What is the platelet count? So you can add in platelet count to kind of get to your mechanisms, looking at the mechanism of aspirin. And then we have our lit and our review generic questions. This again is kind of helping you ask yourself these questions to generate these ideas and these topics that you're interested in, and get to these papers that you want to write that help build towards your research ideas as you become scientists and medical professionals. So, what are the origins and definitions of this topic? What are the major issues and key sources and concepts? And this is kind of more I can't even say that word. But the main questions and the problems that have been addressed to date, a lot of this is answered in systematic reviews that you would find in a good literature search. Okay. So let's stop the share. Okay, though. So that was how to conduct a brief overview of how to conduct a literature search. I hope that was helpful for you. If you do have any questions while writing your paper or just about research in general, please feel free to hit me up. I'm more than happy to talk to anybody about going to graduate school. I've got my master's in public health. I'm a third-year PhD student. In the process of getting I'm writing an F31 grant. I've got a T32 fellowship. And this is all a lot of writing and almost 10 years of being in research. And I started this as an undergrad. So I've navigated a lot of things, including COVID, and trying to also I've gotten into a funded PhD program. So I'm very, very happy to speak with undergraduate people who want to go to med school or want to go to get into a PhD program or master's program and just want to understand research in general. And teaching too. So if you're interested in teaching, please ask me and I can tell you all about the CERTL program as well. So I hope everyone has a great Friday, a good weekend. Best of luck on writing your papers, and I'll talk to you soon.